Good morning everyone. So today I'm going to explain you about VIL, VI and VIH, and which are very simple and easy, and derivation of that I would be explaining. And these VIL, VI and VIH comes from the VTC curve, and the VTC curve, if you're not aware of the VTC curve, I would request you to be thorough with the VTC curve and what is VTC curve and where does VIL, VI and VIH comes under. And whereas VIL, if we go to the VIL in the VTC curve, it is interpreted as logic 0 and it is the highest value, I mean largest value in that. So I would be I will be saying about how does the, how to calculate VIL and what is a simple method and how do we you understand it simple. And according to the VTC curve, we knew that dv out by dv in is -1, and we'll be having this for VIL and VIH, and this is for same for VIL and VIH. So calculate VIL. In this VIL, for NFET it will be in saturated mode, and for PFET it will be in non-saturation mode. Okay, if you were aware of the IDS formulas, so just for main thing you need to know these 2 points are only very more important for the whole calculation of derivation. If you go wrong with these two things, then the whole derivation will be wrong. Okay, just remember that Mn, I mean saturation, N is saturation and non-saturation, and for VIH it's totally opposite, and for Mn it will be non-saturation, and MP it will be saturation. Okay, and the simple thing is just first step is to equate Mn and MP in saturation equation and non-saturation equation. As we know, for Mn in saturation equation is like beta n by 2 VGS minus VTN whole square. Okay, we just made it into that. The similar equation is beta n by 2 is Vn minus VTN whole square. Okay, here we take V in as VIL. Okay, here we take V in as VIL, and again when we go to non-saturation of PFET, that will be of beta p by 2 VGS minus VTP into VDSP minus VDSP whole square. Okay, we took this VDSP as VDD minus V out. Here we just substituted VDSP is equals to VDD minus V out. Okay, we just substituted it here, and this is one equation. We say beta n by 2 Vn minus Vtn whole square, and beta by 2, this whole equation is one equation, and we are equating these two equations. And we'll get the equation 1. Okay, simple method, and we'll get this equation, and this is one equation. For VIL or VIH, there will be two equations. There will be two equations. First one is this, and for calculating the second equation, there are two methods. Okay, I prefer mostly about first method, which is simple and easy. And for the first method, you just take RHS side, and differentiate it. Okay, first of all, you just make it elaborate. I mean, you'll be having here a minus b whole square. You just do that a minus b whole square and differentiate with respect to Vin. Okay, Vin, you just differentiate this whole equation. Okay, when you differentiate, you will be getting dv out by dvn in between. When you take the after differentiation, you'll get these common dv out by dvn. As we said that dv out by dvn is -1, so we just substituted dv out by dvn in -1 in this equation, and we are just going through it, and we are just making 2 VDD and minus VDD cancel, and 2 V out. We just took this and we just took 2 common, and the whole equation comes like bp 2 V out minus V in mod of VTP VDD, and this is one equation. You take as this equation is A, and now we did with RHS from here, and now we are taking LHS, and we are just differentiating it with respect to VIN. Okay, then we are differentiating, that comes 2 into Vn minus 2 Vtn. Okay, then this 2 and this 2 will be cancelled, so beta n into Vn minus Vtn, the LHS derivative output will be there. And when you compare these two, LHS value and RHS value, and you'll be getting beta n VTN minus V in minus VTN, and beta p 2 V out minus V in minus 2 V mod of VTP minus VTT. Okay, and you just multiply in this, and you just multiply, and lastly here you just make common of BTP here, and here BP, beta p here and beta p here, so that you'll be getting equation like 1 plus beta n by beta p V in, and this whole equation, and the whole equation will be in the form of V in into 1 plus beta n by beta p 2 V out. This is the second equation, total second equations. And the simple method is this. Okay, when you go to this method, this is a different one, and you could go in this method also, but I mostly prefer this method. Is lengthy, but it's simple to understand, and you can remember simple steps. In what steps you can do it. And the second one is VIH, the VIH in which Vn is greater than or equals to VIH, so the output is either 0 volts or close to it. So in this I've been said it is the opposite of VIL. There Vn is saturation, here Mn is non-saturation. So MP is saturation. So we just took Mn as non-saturation here, and MP is saturation here. So that in this we have to carefully observe that VDD minus Vin minus VTP is there. Where you used to get Vin minus VTP, here we added VDD also, because VGSP is VDD minus Vn. Okay, you have to just carefully understand this. And for the method one, and again this is one equation for calculating the second second equation, we just took LHS side when differentiated with respect to Vn, and again we substituted dV out by dVn in -1, and we got this beta n LHS side, and again we just took right hand side and we differentiated with respect to Vn, and we just cancelled this 2, and we got beta p is equals to minus VDD VTP. Now thing is, we equated LHS RHS output after the derivative equations. We just equated it, and we took the common here of beta n. Okay, we just took the common of beta n, and the output equation would be Vn into 1 plus beta p by beta n 2 V out plus VTN plus V out. Okay, this is simple method. And where I go to VI, this is the most easiest one of these two, and I would request, I would say just first go with VI and VIL and VIH. That would be better. So VI is midpoint voltage. In this midpoint voltage, V out is Vn. As we see in a VTC curve, there will be a linear graph in it. So that linear graph which touches the curve, we say that's an VI. Okay, that's we say midpoint voltage or Vn, when Vn is equals to V out is equals to. In this stage, and Mn will be saturation and MP will be saturation. So we just equated those two, and beta n is equals to, the equation will be same as I said, VDD minus Vi minus mod of VTP whole square, and we just applied square root on both sides. So whole square and VDD will gets cancelled, and we just multiplied beta n on both sides, and here beta p on both sides. So we just took here beta p as common, 1 plus under root beta n by beta p Vi, and we'll be getting beta p here common, beta p here common, then beta p will gets cancelled. We'll be getting Vi is equals to, Vi is we want, so Vi is equals to 1 plus beta n by beta p, that is equals to VDD minus VTP plus beta n by beta p, which comes on the top, and this whole thing will go to the downside, and this is Vi equation or VM equation, Vi or VM equation. Okay, this is that's it.